So I'll make this fairly brief, and I think Dr. Subhash's talk will actually give a good overview of the AgMIP process. And the AgMIP is the Agricultural Model Intercomparison Project, which I had mentioned yesterday. And this is sort of the process and our methodology in action. Really fast, he gave a nice sort of brief overview of the concerns of climate change in the IGB. We're concerned about a greater variability in the monsoon and also an increase in extreme events, which we've seen and experienced over the last few years. These are particularly stress-prone regions, and there are projections that yields will decrease quite significantly into the future, particularly due to water stresses. And so that's sort of the topic that we're exploring in AgMIP is really how much can we quantify how much yields are going to decrease and what that impact is on food security. And so there are three main regions in the IGB that Dr. Subhash's team is focused on, and they have interactions between a Bangladesh team and a team from Nepal as well. And so they're looking at the upper catchments, which he characterizes as being relatively low productivity, not a lot of infrastructure, and also they have to worry about the downstream constraints that are sort of propagated, environmental constraints that are kind of propagated. The eastern region, also characterized by low productivity and investments in infrastructure. In this region in particular, they experience an underutilization of groundwater, so not being utilized quite as much as other regions. And we can contrast this actually quite nicely to the western region, which experiences, as we've know, a very high degree of productivity. It's very well equipped, particularly in irrigation, and that actually leads, as we've discussed, to an overexploitation of their groundwater sources that they have to be concerned about. And so the farming system here is a rice, wheat, and sugarcane farming system. And in the summer and winter, the farmers will actually grow vegetables as well too. Sorry, and I should mention this is specifically focusing. I don't want to point at you, at the Meerut district. And so in this particular region, they're pretty well equipped irrigation-wise, and so the farmers in the summer and winter will grow vegetables as well. Most households actually also have 2 to 3 buffalo, and so they supplement their income with milk, with sending milk to market. And this is just a general characterization of the farming system that we're working with in this district, and that's information that gets included into our agroeconomic models that I'll discuss in just a minute. And so that's a picture of the site that we're working out of. And so before we talk about how climate change is going to impact the yields, Dr. Subhash has just provided sort of a baseline agroclimate analysis. And I think what you'll see in this talk, if nothing else, is that there's a large degree of model uncertainty. There's uncertainty in our climate models, but there's also uncertainty in our crop models. Dr. Subhash here has run wheat yields from 1980 to 2010 using both APSIM, which is the Australian cropping model, and DSSAT. And the green, what you're seeing is a temperature trend, the mean growing season maximum temperature. As you can see, there is quite a bit of difference in the way that these models are simulating the wheat yields. He's put trend lines on here. I'm not quite sure how significant these trends are, but overall the maximum temperature is increasing and the yields appear to be decreasing overall. Now, we can contrast this to the relatively shorter amount of data that he has for the actual wheat yield. So now we're comparing to observations. And again, in the blue, you see the Australian crop model. In the red, you see DSSAT. And the green is the actual wheat yield, which actually shows quite a bit of decline over this period, over the 1995 to 2010 period. Neither of which, although the trends are declining, neither of the models seem to capture the magnitude of that trend as it is. So again, something to be concerned about as we start looking at what crop models to use and how do we quantify the uncertainty between our crop models. So the first part of the AgMIP process is to incorporate future climate projections into our crop model simulations. And we do that by using all 20 global climate models. What you're looking at here, on top is Tmax, and on the bottom is Tmin, and these are monthly, a monthly time series that you're looking at. And the blue is the baseline climate. So the box and whisker plots indicate the change due to the 20 global climate models. So each box shows the spread of the 20 climate models for that particular month. And overall, the gist of this particular plot is to show that temperatures are increasing. Both the maximum and the minimum temperatures are increasing. And most of the models, though there is a spread, not all the models agree on how much the increase is, but all the models do agree that there will be an increase overall. Oh, and I should mention, this is for RCP 8.5, which is the most pessimistic climate scenario for the mid-century period. So we're looking at around 2040 to 2069. I actually believe the time slice we took was at 2055 for the most pessimistic climate scenario. Now, the picture differs a little bit when we come to rainfall, which is something that we've already discussed, but here's another way to look at it, not in the aggregate, but at a point-based level. And again, this is all just for the Meerut district. And what you can see is, again, in blue is our baseline rainfall series for each month. And the box and whisker plots, again, show our 20 GCMs. The X's that you see are actually the GCMs. You know, when you think about how many simulations there are to do, you could take all 20 GCMs and run all simulations from all 20 GCMs in 2 crop models, and then that go. So we had to sort of confine our assessment, and so we chose 5 GCMs to work with for the future of our project, and those 5 are indicated in the stars. And what we were hoping for was a good coverage of the spread of the 20 GCMs, although you'll see that there are some pretty significant outliers. And really, rainfall is kind of up in the air. There are some GCMs that show that it dips below. There are decreases in the future from the baseline levels, and some show increases. And so that's something that we're considering in terms of how to deal with. Maybe it's the multi-model average. Maybe we want to take a median value, but something we have to be careful of. And so this is another way to sort of depict the changes that you're seeing for our future climate simulations. Each one of those letters stands for a different GCM. And again, this is for RCP 8.5 mid-century. The little red dot you see on the left-hand corner of the graph is our baseline conditions. So growing season minimum temperature and growing season maximum temperature. And most of the models, again, show an increase, but you know, one sort of advantage of this plot is you can kind of see the spread in both directions. And in both directions, it's about 2 to 3 degree spread in what the models are projecting. So depending upon how sensitive your crop model is, this could be something to consider. Okay, so now we'll move on to the crop modeling component, which is slightly out of my expertise. But what we try to do in AgMIP is, you know, we're very conscious of the fact that data limitations can limit how much we can actually say about how our crop model is responding to conditions. And so we like to make sure, you know, what we try to obtain is at least one Sentinel site to really compare our results to. And by Sentinel site, I mean one that has a fairly lengthy data set on nutrient management, on farm management, you know, household income for economic surveys, of household surveys, things like that. And so he's obtained for the Meerut district in 1993 to 2010 nutrient management, and then he's provided information on his calibration and validation there. And then we also collect data on, of course, crop data, the variety, irrigation applications, and other management information. And so these are all things that we are compiling, and we have an interest in making sure that these data are robust and something that we can all access. So To explain some of the variability in the farm system, he's used APSIM and DSSAT, so these are two models we have to consider. The crop that we're going to be looking at is wheat. He has about 76 farms that we are rice wheat system farms that we'll be simulating. And there's a wide variability of sowing dates and dates of harvest. There are 5 cultivars he's looking at, and then you'll see he also details the number of irrigations and fertilizer applications. And of course, these vary across the farms, and that's something that we have to consider when we start modeling this community of farms. Okay, so what are the projections on the yield exactly based upon the climate projections I showed you earlier? Well, he's contrasted, so what you're looking at is the percent change in yield for the 2 climate models, the 2 crop models based upon the 20 global climate models. And ultimately what you can conclude from this is that DSSAT is actually giving us a much more optimistic view of how wheat will respond in the future when compared to APSIM, which actually shows declines of about 5% in some cases. That's under mean change only. There was a comment here that I was happy that came out earlier, and it's something that we've talked about yesterday as well too. We have to look at mean changes from the climate, but we're also looking at changes not just to the mean, but also variability changes in terms of, mostly in terms of rainfall, variability in rainfall. And you can see that the results differ, but not that much between these simulations. And that's sort of a methodology that we're still kind of refining. But overall, DSSAT paints a bit more of a rosy picture, even given the same GCMs, and these are the same weather files that are going into these models. So he also showed the same breakdown, the difference between DSSAT and APSIM, but now with and without, or I should say without and with, the CO2 fertilization effect. So in one case, he left out the increased CO2. And again, DSSAT paints a bit of a rosier picture in terms of not projecting as steep a yield declines as APSIM does. And then, of course, once we include the fertilization effects, we get back what the plot that we saw a bit earlier. So, when it comes to thinking about how farmers will adapt to these changes in the future, we have to think about what we've been trying to do in AgMIP is really integrate and reach out to a whole variety and levels of stakeholders, from the national level down to the farm level. And we've had many meetings, and the groups have conducted a lot of sort of stakeholder research and used the stakeholder input to formulate adaptation strategies moving forward at various levels. And we're still, that's still a work in progress. But what it amounts to is the formulation of what we call representative agricultural pathways. These are supposed to be agricultural analogies to the representative concentration pathways, or RCPs. And so each team would, working with their stakeholders, formulate a narrative for what adaptation might look like in the future, or what economic, socioeconomic, and climatic situations the farmer might face, or a community of farmers might face, and then how they might go about responding to that. So in this particular narrative, they looked at climate change as having an adverse impact on wheat, on the costs of wheat increasing substantially, on imports being inadequate to meet the domestic demand, and therefore the government liberalizes wheat imports and invests in new food chain logistics, and also boosts R&D for developing new cultivars. And so that's the general narrative that they'll follow through in the rest of their assessment to really look at what a potential outcome of climate change might be. And again, this is to show you, so what they've done now is taken the yields, or rather the relative change in the yields from each of the global climate models. So these letters that you see on the side indicate a different global climate model. And they've taken these relative changes in yield and put them through a trade-off analysis model that's simulating a population of farms. So it's sort of a heterogeneous population of farms within the Meerut district. And this would be the 76 farms that they included. And of course, it's not really that much of a surprise, but given the rosier picture DSSAT was painting, in each case, DSSAT actually showed a gain, so it's a negative net loss, and so we should work on a better way to depict that. But so the red actually indicates a gain. And so for every DSAT simulation you see, there's a gain, whereas APSIM is actually projecting a loss. So how do we go to the stakeholders with this kind of assessment and try to figure out what to do? These are the uncertainties that in AgMIP we're trying to quantify before we go to the stakeholder. So something to be aware of. And again, this just shows something similar, and it kind of depicts it more now within that 76 farms under APSIM conditions. This is supposed to show that about 46.7% gain. Under DSAT conditions, the gain, the percentage of the population that gains is a bit higher. And again, this is all under RCP 8.5 mid-century conditions. So again, depending upon what crop model you go to the stakeholders with, you might get a different result. You know, again, this is something that we're trying to consider on how to quantify this uncertainty. Again, just another way to visualize what we were talking about now for each individual global climate model that you see on the bottom. The baseline is indicated in this purple line, and what you're looking at is the net farm return. And in each case, APSIM projects a net loss or a net decrease in farm return, whereas DSAT shows an increase in net farm return. So a little bit difficult. I think this is one of his last slides. So now, in addition to, and this is probably a step after what I just shown, I think our first step would really be to quantify this uncertainty and try to figure out a way to communicate why this uncertainty exists and if the models can't be improved, and where the models are failing if they are. And so after we establish that part and we start implementing the adaptation side of things, the IGB team, Dr. Subhash's team, has it in mind to actually integrate sources, sort of a diversified farm, diversifying the farm income by looking at aquaculture solutions, manure collection and storage quality, and also looking at feed supply and demand, opportunities for milk and meat production. And the idea is that if we can sort of synthesize these things into our projections of crop yields and adaptation to changing crop yields, this can form part of the package that we put forth to stakeholders. And so the need of the hour is trying to figure out how to integrate these things. Of course, that comes after the model improvement and trying to quantify this uncertainty. And that's about it. I know that was very fast.